25 kilogram box moving at constant velocity. Why do we need a force to move a box? Once I kick it, shouldn't it just keep going forever? That's what Newton said. What stops it? Friction. So force of friction fighting me. So I need a force of pulling to make it go that way. Agreed? Okay. Now, if it's going at constant velocity, which one's winning? None of them. So force of friction, you would say force I need to pull with is equal to force of friction. Are we in agreement? Force of friction formula is equal to mu force normal. So far, so good. And now it says here that mu is equal to 0.21. In agreement? And force normal is a little tricky because it doesn't give me force normal. How am I going to find my force normal?
It's 78.
78 is my mass, not my weight. Those are different.
And it has to like hold that up.
It's got to hold that up, so there's a force of weight pushing down. There's a force of normal pushing it back up, saying you can't go in the ground. So force of normal is equal to force of weight as well. So therefore, force of weight we know how to calculate because we did a whole bunch of them in the last worksheet. I hope you did those. Okay, so then force of weight is equal to, you said 78 for my mass, times 9.8, which means my force of weight is equal to? I got 764 newtons. In agreement? And if that's my force of weight, that's also my force normal, which means I can slap it in here. Times 0.21, and I get my force of friction is equal to 161 newtons. So how hard am I pulling? 161 newtons, because I got to break friction. Break even with friction. Yes, ma'am. You got it? I figured you would, but I wasn't sure. So they kind of went past you. Get any more questions on that? You're good. What time are we out of here? I'll put it on my thing. Where to put it? Oh!
So this is the force.
Put down. Who's got what time we're out of here?
Mine is the force friction, so this will be
1247.
12:47. Awesome. Yes, ma'am.
Okay, I'm still stuck with 8. So
Still stuck with 8? 8 is hard.
I don't think I did it right. You can't. I'm not certified as
so I found the acceleration.
78.1. Look at that.
So at F equals ma,
Yes.
that turns into that. So that F works on the force of force of friction.
Right. That's the force that you stop me, and friction what's stopping me. Good. Love it.
1 times 105. We'll do multiply by 105
Yeah.
to get, so that's a force of friction, which is 8,000.
Love it.
But you use that.
Love it.
Our force of weight.
Yeah.
Love it.
That gives us a huge number. It's like 7 points.
Okay. So read the question fully.
Oh, you can't. So you can't also.
Yeah.
So
He's
this
traveling at.
this.
He's traveling at 50 miles per hour, 4 meters from a tree. That's about this far from a tree. And we're saying stop with your bicycle brakes.
So we did do it.
You're not stopping in time. You would need a coefficient of 7, which would be 7 times harder stopping than you lift it off the ground.
But in most cases.
Bikes don't do that. They burst into flames and not even try.
So I did it right.
Yeah.
But in most cases, our coefficient.
It should be between 0 and 1. So one of the ways you can say is coefficient of 7 for bicycle? Can't. And I don't care how friction full your tires are, 7's too high.
That's the first point. No.
Love it.
This is just the force.
Okay, that's force normal, correct?
Oh, but.
Okay, so now you can do force friction, you know what force you need? So you figure out how much force you need to stop. So you got acceleration. How much force do we need to stop a 105 kilogram person that needs that much acceleration? That's the weight, you said. No, you're right. You're right. That's I don't like force, but this force is stopping. This is force of friction or something.
82.03.
I like it, force friction.
102.
That goes up there. Yeah. Same going this way. I told you a Newton of a cross country skier, that's his weight. It's already there.
You multiply,
No.
Oh.
I mean, I could go backwards and find his mass, but why would I want to?
So then the force of weight
Just
is
597. I get it to you in Newton, so that means he's already got his weight.
What do you?
for this
Oh.
new force.
Uh-huh.
It's
That times. That's right.
Okay?
okay. Hopefully
And
that's
then
real.
friction, if he's fast, you use 40 to keep going. What's force friction? Determine constant velocity, he has to like 40 meters to keep going. 40. The force friction is 40 meters.
Oh,
Yeah. Which is impossible for a new friction.
Not in this one. In this case, if I'm going constant speed and I'm applying 40 newtons this way, I'm going constant speed, somebody's applying 40 newtons
Unless
back.
he applies something's own force, which is what I was.
Friction, right? What stops it?
He can also.
So in order to constant speed, I have to keep going 40 newtons this way. That means that the ground's going to be pushing 40 newtons back.
Yeah, basically.
Okay.
Yeah.
No, 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 no. Yeah. Oh no, I'm recording for like 10 minutes. Oh, I didn't pause it. Oh no. No, what's the answer to number 2? Mr. Witter.
Number 2.
Yeah.
I got 65.7.
65.7?
Yeah.
What you got? Okay, 65.7. I need answer to number 3. Who's got number 3?
It's.
0.1.
0.12? No units because it's coefficient of friction, huh? All right.